Alright, so now we're going to look at names for ionic compounds, which really we've already kind of done. But I'm just going to re-clarify a few things, because when you do formulas, you have to read a name. Well, now we're going to do looking at a formula, we're going to write the name from it. So we kind of did the name to formula part, now we're going to do the formula to name part, which really is just the opposite way. So you've kind of already done this. So the rules here, rules or guidelines, I guess. First thing is if it's cation, you use the elements for full name. So if it's a normal cation, meaning it's a metal, it's going to be sodium. Okay, full name. If it's a transition metal, that's the only little part you got to look at. Okay, if it's in the D block, you have to indicate the charge with the Roman numeral. So you have to put in parentheses, not how many of them there are, which what everybody always wants to do, but the Roman numeral of the charge. Okay, which means you're probably going to have to figure out what the negative end of it is to figure out what the positive end is. Okay, then we have an anion, okay, which is the non-metal. If it's a single element, you put the root plus IDE. So if it's chlorine, it's chlor or chloro, okay? Chlor and then ide. If you don't quite cut that anion off in the right spot because it's different spots for different elements, okay, I'm not going to mark you off if you put sulfuride. It's really sulfide, okay? But that kind of thing I'm not that picky about, all right? And now if it's a polyatomic, you have to then write the name of the anion. So that's easy. So if it's, SO4, then I would just put sulfate. I don't put sulfateide. Okay? So the only way you really get good at these is doing a bunch of examples. So we're going to start and do some examples here together. Alright, so let's look at NaBr. Okay, so the first thing I look at is, okay, what's the cation part? Alright, well the cation is the metal. Alright, so I see my metal there. Well, what metal is Na? Okay, well metal is, Na is sodium. I ask myself, stop, is that a transition metal? Sodium is on the left side of the periodic table. It is not in the D block. It's not a transition metal. I'm done. Okay? Then I go up here and I look at Br. Is Br a single element type or is it a polyatomic? Well, Br is just one element. It's bromine. So then I'm going to just write it as, alright, here we go. I'm going to put bro. Okay? And it's not bromoide, okay, or brominide. It's bromide. You take the root word and end the IDE. So sodium bromide is NaBr. Okay? Now let's look at CaCl2. Alright? Start off with the metal, Ca. Ca is calcium. Is it a transition metal? No, it's not. It's in group 2. Okay? Now I'll go to the second part here. I have Cl2. Now I've got more than one ion. I have 2 chlorines. But do I have more than one type of ion? No, I have the same type. So it's still just a monatomic ion. It's just that element. So I'm still just going to do chlor. This is chlorine. What we do is we do chloride. So that is calcium chloride. Alright, I do nothing with the 2. Okay, I don't do anything with that 2 because it's always going to be a 2. Okay, so I don't have to put dichloride or anything like that like we do for carbon dioxide because I only ever need 2 chlorines to go with that calcium. Because where did that 2 come from? That 2 came because I had 2 positives for the calcium and 1 negative for the chlorine, so it balanced out. Well, does calcium ever change? No, calcium never changes. So that's why there's no number telling me how many of those I have. We don't care because it never changes. Alright? And that'll be more of an issue in the next chapter. Alright? But, for right now, okay, look at the next one. I have Cu. Well, Cu is copper. Alright, then I ask myself, is copper a transition metal? Yes, copper's in the D block. So that means I'm going to need some kind of charge there. Alright, which means I've got to look at my second type of my of element here. Okay, and I look at iodine. Alright, which is I. It's not a polyatomic, it's just iodine. So what I do is I put IO, and it's actually iodide because I end it in the IDE. Okay, I still need the number that goes there. Well, that means we got to backtrack a little bit. Okay, and look at the negative ion. Well, okay, I look at iodine. Iodine's in group 17, which means it's a 1 negative. And there are 2 of them, which means this total here is a 2 negative, which means that copper there had to be 2 positive. So it's copper 2 iodide. Alright, try the next one. I have Ni and O. Ni is nickel. Okay, the Ni, is that a transition metal? Yes, it's in the D block, so I'm going to need something there. Now look at O. O is just oxygen, so I'm going to do oxide. Now I got to go back and look at what the charge for nickel is going to be. Well, I find oxygen. Okay, oxygen is a 2 negative. Okay, there's only one nickel, so that means that has to be a 2 positive again, nickel 2. Okay, I go on to my next one here. I have KOH. K is potassium. Is that a transition metal? No, so I don't care, so no parentheses, I keep going. OH. OH is not just one element, obviously, it's two, it's an oxygen and a hydrogen, which means you flip over the back of your periodic table, should be on the back, and it tells you that OH is hydroxide. If it's more than one element type, look on the back of your periodic table, it should be right there listed. Don't try and make it up. Every year somebody tries and make it up. Okay? If I've got Cu and NO3, and there's two of them. Alright, I start with Cu, where I did Cu earlier. Cu is copper. I know from earlier that it's a transition metal. And then I'll look at this part here. I find NO3 on the back of my table. And it tells me that is nitrate. Again, there are two of them, but I could care less about the name with there being two of them. Except if I need to know the charge. And in this case, I need to know the charge. Because I need to know copper's charge. So, I'll look at it and say, okay, I look on the back of my periodic table, and it tells me that NO3 is a 1 negative. There are two of them, though. So that means it's a 2 negative, which means copper is a 2 plus. Okay, keep going. I have NH4ClO4. Okay, well, NH4, if you don't know where to stop, look on the back, alright? You're not going to have nitrogen and hydrogen and then the ClO4. NH4 is one thing. On the back, that's ammonium. Polyatomic ion. Look on the back of the periodic table for that little sucker there, ClO4. That's not something you have to memorize. Look on the back. It's more than one element. That's perchlorate. Alright? Just be careful with the charges. I'm going to kind of give you one more example here for a second. Because we didn't have to do it for any of these ones. I should have put it on here. If you have one, for example, and we'll do it off to the side over here, alright? Okay, if we, for example, had Cu2O, alright? And say, okay, how would I name this? Well, Cu2O means I'm going to look at it again, I'm going to have copper. I know it's a transition metal, so I need a charge. Oxygen, it's going to be oxide. It's a little different than the one that we had, alright, because it's Cu2O. So what that means is that this is a 2 negative still. Okay, so this has got to be a 2 positive still. But I have two coppers to split that 2 positive across. So this here is actually copper 1 oxide. Think about if you're going to do that one backwards. If I were to do copper 1 oxide, I would say, okay, well I would have Cu, it would be a 1 plus. I'd have O, that's a 2 negative, it would be Cu2O. Okay. Always work backwards to kind of check your work. So the difference there between copper 1 oxide and copper 2 oxide, this one's a little bit more difficult. This is an extra example there.